All right, so we know when we solve an equation, what we're looking for is the value of a variable. We're trying to find these solutions or roots of the equation. And essentially, we're trying to find the value that satisfies the equation that makes it a true statement. And so the set of all of the solutions is what we call the solution set. And in order to find our solutions, what we do is we try to isolate the variable or get it by itself. So we're going to start with some simple linear equations, and so these should be rather simple. If I'm trying to isolate x, then of course I need to move this 5 to the other side. And so I end up with 4x equals 24, divide by 4, and I find that x is 6. In order to check my solution, I replace the x in the equation with 6 and ensure that this is a true statement, which it is. So I know x is equal to 6. Okay, some of our equations are a little bit more complex. We need to distribute first and then combine like terms and continue with the process. And so all of this is stuff that you should be familiar with. We're going over it just to make sure that we are all on the same page. Okay, it combines my like terms. I'm going to move the 6s to the opposite side. I move the 4 over, so now I have 2s equals 10, divide 2, and I find that s is 5. If I replace s with 5 at the beginning, this becomes 2 times 5, or 10, plus 1, which is 44, equal to 2 times 5 is 10, minus 5 is 5, times 3 is 15, and 15 and 29 is 44. All right, so that one worked as well, and my solution is s equals 5. All right, and now these last two we have fractions, and sometimes I know that we really don't care for fractions, and so what we can do is we can use their least common denominator in order to eliminate the denominator of the fraction. So remember that the least common denominator is the smallest thing that they all have in common. And so in C, their least common denominator is 28. Now, in order to eliminate the denominators, I take each fraction and I multiply it by 28. And basically what happens is the denominators cancel out part of that 28. And I'm left with only smaller pieces. And so this cancels, and I have 7 times x minus 3 equal to 2 times 5 minus 4 times x plus 5. And so we'll distribute here. All right, and so we'll add 4x and add 21 on both sides. And so I end up with 11x equals 11. So x is 1. And plugging in, we should find that that is correct. And then we'll wrap it up with d here. This is times 21. So 3 goes into 21 7 times. 5 times 21 is 105. And 7 goes into 21 3 times. Distribute. So I have 7x plus 7 equals 99 minus 3x. I'm going to bring the 3 over to the left side, bring the 7 over to the right. And so I have 10x equals 92, divide by 10, and I find x is 9.2. Okay. Now, the next thing we need to look at is how we solve rational equations, and the process is going to be similar as for the fractions. We're going to find the least common denominator and multiply by the least common denominator. Okay, and remember that the least common denominator needs to account for everybody. So in number 1, my least common denominator needs to be 18x. so that everybody is accounted for. Now when I multiply 18x times 5 over 2x, okay, I see that my x's cancel, and 2 goes into 18 9 times, so this is 45, equals, the 18's cancel, 17x, and this gives me 6 times 1, 6. So 45 plus 6 is 51, equals 17x. 51 divided by 17 is 3. Now I should go back and check to make sure that this works in this particular situation. And so I have 5 over 2 times 3, which is 6, equal to 17 over 18 minus 1 over 9. So if I change these so that they all have a denominator of 18, this is 18 and 15, it's times 3. This is 18 and 2 because it's times 2. And of course 17 minus 2 does give us 15, and so that is our solution. All right, and we'll do the same thing over here. For b, my least common denominator that I'm going to multiply everything times is 3 times x minus 2. So since the first fraction has the x minus 2 already, those are going to cancel, and I'm left with 3x. On my next fraction, same idea. The x minus 2 cancels, so I have 3 times 2. And then finally the 3 cancels, and so I'm left with x minus 2. So this is 3x equals 6 minus 2x plus 4. Swing this 2x to the other side and divide by 5, and we get 2. Now what's the problem here? If I replace my x with 2, these denominators become 0, which gives me an undefined value. And so this is what we consider to be, so this is what we call an extraneous solution. Okay, it's a solution that we get when we solve the problem. However, when we check it, it doesn't work. And so this example B actually has no solution. We are never going to find any value that makes this a true statement. All right, and we'll do one more of these. So here you should recognize that x squared minus 16 is the same as x plus 4 and x minus 4. So this is my least common denominator. Now when I multiply my first fraction times the least common denominator, the x plus 4 cancels, and so I'm left with 1 times x minus 4. On my second fraction, the x minus 4 cancels, and so I'm left with x plus 4. And in the last one, the whole thing is going to cancel, and so we're left with just the numerator of 22. And so now we have x minus 4 plus x plus 4 equal to 22. Minus 4 and plus 4 cancel, so we have 2x equals 22. Divide by 2, and x is 11. Now let's just check and make sure that this works. So 1 plus 11 over, 11 plus 4 is 15. Plus 1 over 11 minus 4 is 7. Equals 22 over 121 minus 16. Okay. Common denominator of 15 and 17 is going to be 105. And so this becomes 7 over 105 plus 15 over 105 equals 22 over 105. And of course 7 plus 15 is 22. So x equals 11 does work. Okay, and then the last thing we have here is just another application question. And so the mathematical model P plus x over 2 equals 37 describes the percentage of Americans who smoked cigarettes P X years after 1970. To use this model to solve A and B below. Does the mathematical model underestimate or overestimate the percentage of Americans who smoke cigarettes in 2010 and by how much? So 2010 from 1970 is 40 years. And so we're going to take the percentage, and that should be equal to, the percentage plus 40 over 2 equals 37. So 40 over 2 is, of course, 20. And 37 minus 20 is 17. And so in the year 2010, the graph says it should be 19. So this is an underestimate. By 2%. And then B says, use the model to project the year when only 7% of Americans will smoke. So this time we have x7, which is the percent. X over 2 equals 37. We're going to subtract 7 on both sides, and then multiply by 2 gives me 60. So this is 60 years after 1970. And so that's the year 2030.